There was a moment, about 2.5 million years ago in what is today South America, when a terror bird encountered a saber-toothed cat for the first time. Neither of the two knew what the other was, and that was the beginning of the end for the deadliest bird that has ever existed on this planet. Terror birds were not birds in the sense that your brain evokes when it hears that word. They were predators. Predators with a curved beak and a muscular neck that could reach more than 2 meters in height and weigh as much as a heavy adult human for almost 60 million years. These creatures dominated South America in such an absolute way that the other animals of the continent had not even developed effective defenses against them. They did not need to develop them. There was nothing else to fear. But there is something that no one has told you correctly about the terror birds, and it is what changes everything you think you know about them. The most widespread myth is that they were slow, clumsy, too big to be efficient hunters. The popular image shows them as giant birds that chased prey in a straight line, but that is completely inaccurate. What the fossils of their legs reveal is something else. They had a musculature in their lower limbs designed for rapid acceleration and sudden changes of direction. The leg bone, the tarsometatarsus, was proportionally longer than that of any current running bird, which means that each stride covered an enormous distance with minimal energy expenditure. They did not chase their prey. They intercepted them, calculated trajectories, and when they reached the correct range, that beak, which in the largest species measured the same as the forearm of a human being, struck downward with a force equivalent to dropping an object of several kilograms from a considerable height. They did not tear. They pierced. The impact was enough to destabilize animals much heavier than them. There existed at least 17 different genera of these birds throughout their history. They were not a single species. They were an entire family of predators, each one adapted to a slightly different strategy. The smallest, barely a meter tall, hunted prey the size of a rabbit with a precision that did not need brute force. The largest, like the kelenken, which lived about 15 million years ago in what is today the Argentine Patagonia, had a skull almost 70 centimeters long, larger than that of any known bird in the entire history of the planet. Just the skull, 70 centimeters. For that to have real scale, place your forearm from the elbow to the tip of your middle finger. Now imagine that this is only the head of the animal in front of you. The kelenken weighed approximately 250 kilograms, and it is estimated that it could run at speeds of between 40 and 50 kilometers per hour over short distances. It was not a long-distance runner. It was a sprinter with the size of a bull. Now place yourself for a moment on that continent 3 million years ago. The smell of the environment is dense, humid, with that heavy vegetal layer that characterizes the tropics of the southern hemisphere. The ground under your feet is soft, dark, with roots emerging directly. It comes from all sides, bouncing off every vegetal surface. And in that landscape, the dominant sound is not the roar of any feline. Because felines have not yet arrived, what is heard is the fast, almost silent movement of something that hunts without warning. South America at that time was an isolated world for more than 100 million years, a closed evolutionary experiment, and the terror birds were its most extreme result. To understand why that isolation matters, one must understand what isolation produces in ecosystems. When a continent remains separated from the rest for tens of millions of years, its animals evolve without the pressure of external competitors. That sounds like an advantage. Does it not? It is not. Animals that have never faced a certain type of threat do not develop defenses against that type of threat. South America was a world in which the rules had been written by its own inhabitants for so long that no one questioned those rules. Herbivores had learned to flee from terror birds. Terror birds had learned to hunt herbivores. The system was stable, efficient, and completely unprepared for what was coming. But then something happened that no evolutionary model would have predicted. The tectonic plates moved. The ocean floor between North and South America was pushed upward for thousands and thousands of years until a strip of land formed that connected the two continents, the Isthmus of Panama. A connection so narrow that at its thinnest point, you would barely have to walk about 80 kilometers from coast to coast. And that strip of land was the greatest ecological catastrophe that South America has experienced in all its history. Through that corridor arrived pumas, jaguars, wolves of a type already vanished, but that hunted in coordinated groups, and the macarodonts, the large felines with curved canines, creatures that had spent millions of years competing against other equally lethal predators in the north, and that arrived in the south with all that experience incorporated into their biology. The north was not only larger in surface area, it was harsher in ecological terms. At multiple moments in its history, North America had been connected to Eurasia through the Bering Strait. When sea levels dropped sufficiently, that meant constant exchanges of fauna with Asia and, through Asia, with Africa. North American predators had been forced to compete against predators from 3 different continents for millions of years. They were hardened in a way that South Americans, in their isolation, simply could not be. And here is the detail that most documentaries omit completely. Terror birds did not disappear because the new predators hunted them directly. They disappeared because they stole their job. The large herbivores of the continent, those that constituted the base of their diet, began to be pressured by competitors from the north who displaced them toward the margins. The chain broke from the base, not from the top. When prey decreases, the most specialized predator is always the one that loses first. And terror birds were extraordinarily specialized. They could not simply switch prey the way a generalist feline could. Their beak, their hunting mechanics, their entire design was calibrated for a specific type of target. When that target became scarce, they became scarce too. This holds a lesson that goes far beyond paleontology. Extreme specialization is at the same time the greatest strength and the greatest vulnerability of any species in ecology. In economics, in biology, the perfect specialist dominates as long as the environment remains stable. As soon as the environment changes, the generalist wins every time. Terror birds were the most perfect specialist that South America had produced, and the Isthmus of Panama changed the environment irreversibly. But there is a chapter of this history that almost no one tells: the moment when terror birds tried to cross in the opposite direction. A genus called Titanus reached what is today the southern United States. Fossils found in Florida and Texas confirm it. It was one of the most robust species of the group, capable of reaching 2 meters in height, with structures in the remains of what were once wings that still generate debate among specialists, because some fossils suggest that it retained structures in the upper limbs more developed than other genera, which could indicate that it used those proto-appendages in hunting in some way that we do not fully understand. It was trying to conquer the north. The problem is that the north was already occupied by predators that had spent millions of years refining their strategies in a much more competitive environment. Titanus could not take root. Its distribution remained confined to the southernmost states. Without expansion, without diversification, the finish line was also the containment line. Let us look now at something that fossils show us about the exact mechanics of a terror bird hunt, because here is the piece that most changes the image we have of them. The terror bird did not use its beak to hold. It used it to deliver a single precise blow. Studies of their skulls reveal that the bone structure was reinforced in the vertical axis, but was relatively fragile on the sides. That means it could not shake its head from side to side like a crocodile does. If it did, the skull gave way. What it did was calculate the exact point of impact, drive its head downward with all the force of its neck, and withdraw. Strike and withdraw. It was a technique more similar to that of an eagle than to that of a carnivorous mammal, but on a scale that no eagle has ever reached. That very specific design also reveals something about the type of prey it hunted. A high-energy vertical blow is devastating against animals with an exposed spinal column, against prey that do not have armor on the upper part of the body, against the original South American herbivorous fauna that had not developed that type of protection. It worked almost surgically, but against a feline that moved laterally, that attacked from low angles and changed direction unpredictably. That same design became a problem. The terror bird needed the prey to do what prey had always done, and the new predators from the north did not follow that script. Think about what that implies for an animal that encountered a feline with curved canines for the first time. The terror bird expected the prey to flee in a straight line or freeze. Smilodon did neither of those things. It was a feline that charged head-on, that used its body weight to tackle, that attacked the base of the neck in a way completely different from anything the terror bird had encountered before. Its instruction manual had no page for that scenario. Now then, what happened on the other side of the equation? How did a Smilodon see a terror bird? It had no page for that either. An animal 2 meters tall that did not flee, but instead turned and struck downward with something that was neither a claw nor a horn. Something completely different from any threat that Smilodon had processed before. The first encounters between these species must have been chaotic in the most literal sense. Neither of the two had instincts prepared for the other. And in that type of situation, the advantage goes to the animal that learns faster or the one that has more response options. Felines, with their wider repertoire of behaviors, had more options. Terror birds, specialized to the limit, had fewer. This leads us to something that has direct consequences on what you see today when you observe the fauna of Latin America. All the large felines that live in the Amazon, all the canids that roam the Pampas, all the giant otters of the Pantanal have their origin in that invasion from the north. The jaguar, which today is a symbol of the Amazon, is not a South American animal in evolutionary terms. Its ancestors crossed through the isthmus. What we call Latin American nature, that which appears in documentaries with the jaguar as the absolute protagonist, is the result of a massive substitution that occurred approximately 2 million years ago. The original predator of that continent, the one that dominated for almost 60 million years, does not exist. And the one that replaced it came from the outside. This reason why northern predators won was not just biological, it was geographical in a very specific sense. When a North American animal crossed toward the south through the isthmus, even before stepping onto the continent, it had already passed through hot and humid zones similar to those of its destination. If it arrived, it meant that its biology could handle that environment. The filter had already worked before it set foot on new land. But when a South American animal traveled north, for hundreds of kilometers, it kept finding a climate similar to that of its origin. It felt on familiar ground. And then suddenly, upon reaching the central volcanic belt of Mexico, the environment changed abruptly. Drier, colder, with marked seasons that the South did not have. Many did not survive that change because their biology had never needed to prepare for something like that. Geography is not neutral in this particular story. The northern continent had a structural advantage that did not require a single direct encounter. However, there is a group of animals that resisted better than any model would have expected. The large armored herbivores, the glyptodonts, with that armor of fused bone plates that could weigh more than a ton, and the ground sloths, which were not the slow and harmless animals that the name suggests. An adult ground sloth could stand on its hind legs and reach a height of 5 meters. Its claws, disproportionately long in relation to the body, could swing an arc with enough force to deter any predator that did not want to take a risk. Some lineages weighed more than 4 tons. And 4 tons of animal that can stand up and strike is a complicated problem even for a Smilodon. A lineage of ground sloth called Megalonyx reached Alaska, crossed Central America, traveled through the entire north of the continent, and reached the vicinity of the Bering Strait. Those are thousands of kilometers of expansion in an environment completely different from the tropical one where their group originated. The giant herbivores of South America turned out to be more resilient to the invasion than their own predators. The reason is counterintuitive, but it has a perfect logic. Northern carnivores had arrived optimized to hunt North American herbivores, the deer, wild horses, and camelids. When they arrived in the south and encountered an adult glyptodont, they encountered something for which no previous hunting strategy served them. The armor of an adult glyptodont was formed by bone plates. The osteoderms fused together, forming a shell that in some individuals reached 5 centimeters in thickness. It was not decorative. It was functionally equivalent to medieval armor, but integrated into the animal, seamless, without weak points on the upper part of the body. The only way to gain access was to surround the animal, wait for a moment of vulnerability, and try the limbs or the neck. And meanwhile, that tail, which in some species ended in a bony mass with protuberances that paleontologists describe as similar to a mace, could swing with enough force to fracture bones. The risk of attacking an adult glyptodont was so high, and the reward so uncertain that many predators simply did not try it. Small marsupials also resisted in a notable way. Opossums, those animals that today you can find in the backyards of Mexico City or on the fringes of any Latin American city, are direct descendants of the marsupials that survived the exchange. Their secret was extreme adaptability in diet and a defensive tactic that remains one of the most striking in the animal kingdom, pretending to be lifeless with such physiological conviction that predators lose interest. It is not a learned trick, it is an involuntary response of the nervous system. The animal literally enters a state that mimics the physical signs of death, and it worked during the exchange just as it works today. At this point in history, with the herbivores resisting and the terror birds retreating, something else was happening that no animal on that continent could perceive. The climate was changing. The end of the Pliocene, 12 and 10,000 years ago, brought with it a global warming that melted ice sheets and reconfigured ecosystems across the entire planet. The grasslands that had sustained the large herbivores for millions of years were fragmenting. The vegetation corridors that connected feeding areas were interrupted, and large-sized animals, which need vast stretches of territory to sustain their caloric needs, began to find that the world was getting small for them in a way that was not visible, but that was absolutely real. An adult glyptodont needed to consume enormous amounts of vegetation every day to maintain its metabolism. A 4-ton ground sloth required wide territories. When those territories began to contract and fragment, the population of these animals began to decline. In a way that fossils clearly document a progressive decrease in the number of individuals and in the diversity of species long before any other additional pressure entered the equation. And then humans arrived. The first human groups to set foot in South America approximately 20,000 years ago found a continent in which the original large predators were already scarce or had disappeared, but where giant herbivores still existed. And those herbivores that had survived the invasion of northern carnivores and had partially resisted climate change, had no experience with a threat that hunted in a group, coordinated strategies from a distance, and used projectiles. The glyptodont had developed an armor impenetrable to any predator that needed physical contact to cause damage, against a group of hunters who could injure from afar and surround without exposing themselves. That armor was irrelevant, the herbivores, which had resisted the almost impossible for 2 million years, disappeared in a period of time that in geological terms is practically an instant. And this leaves us on the exact edge where current science stops without being able to give a definitive answer. How much of that final extinction was a consequence of climate change? And how much was a direct consequence of human pressure? The data points in both directions with a force that makes it impossible to close the case. On some continents, the megafauna disappeared before human arrival. On others, it disappeared just after. South America is exactly on the ambiguous margin of that evidence, in that uncomfortable space where the two factors overlap and separating them turns out to be almost impossible with the available fossils. What we can say with certainty is what remained: the jaguar, the puma, the maned wolf, the spectacled bear, all descendants of northern lineages, the opossums and some small marsupials, survivors of the original world, and a fossil silence where, for almost 60 million years, there was something that had no equivalent anywhere else on the planet. That bird of almost 2 meters in height, with the beak capable of piercing whatever it found ahead. That creature that had been the axis of an ecosystem for longer than any mammal can claim, disappeared without leaving anything like it. No descendant to occupy its niche, no reduced form to fill the space it left. The ecosystem it generated had no continuity, and the continent that hosted it for 60 million years has been functioning for 2 million years with the fauna that came to replace it. The next time you see a jaguar in a nature documentary and think that you are seeing something deeply Latin American, remember that this animal is the winner of a war that started when an 80-kilometer strip of land formed. And the loser of that war was something that had no name in any human language, because it disappeared millions of years before anyone existed who could name it.